the eSpeak or eSpeak NG phonemizer, or that phonemizer thing. And then for license reasons, I think we switched to the Groot version. And now when I got it right, you implemented the fallback or an additional way using the old eSpeak version. So is there a reason for switching or adding the second option for eSpeak?
So the main reason is basically the quality. I mean, there's Groot. It's better than many other libraries for phonemization, but still it is not as good as eSpeak, and it doesn't cover a lot of languages that has already been covered by eSpeak. So this is mainly the reason, and also there's the compatibility issues with our previous models, because the release models are trained with the eSpeak library and using it as a phonemizer. But now, once we switch to Groot, there's slight differences, and then those differences cause some issues with the pronunciation of the model. So basically, I
can agree, because I've trained with Groot, and it's a good start. But compared to the eSpeak version, some phonemes in the German language, at least, were worse than with the eSpeak. And but if I choose to train a new TTS model with eSpeak phonemizer, is this now or in future compatible by using the simple pip install TTS process, or is it focused to be just compatible for the Groot versions or models?
So the way I try to design it right now, so it is in progress actually. So it's happening and it's not released yet. So just let me close my door. There's some noise coming through. Just a second.
Hey Josh, nice to see you.
Okay, so the priority will be Groot actually. So if you just like pip install TTS and start to train a model, the default will be Groot, because we cannot really install eSpeak due to the license issues. But if you install eSpeak externally, and then for languages that are in eSpeak, the default will be eSpeak. But if you don't install it, the default is Groot for any language you use, if it is supported by Groot. And so, for example, there's Japanese and Chinese, they're not supported by any of this. And there are special phonemizers set for these languages. And if you just provide something out of vocabulary, totally like a new language, then maybe you even need to implement a phonomizer. But this new API basically will make it quite easier than before to just implement those new phonemizers, and you can deal with that. So yeah, I guess I answered more than you asked. So
no, perfect. Thank you.
Okay. Another question, comment, feedback, anything? Okay, Marco.
Yes, hello. So my name is Marco Barnik. I'm from Luxembourg, and I have first a very simple question. I have seen that when doing training, there are sometimes or very often messages that some code is deprecated by in the dependencies. And there is my question: what shall we do in such a case? Shall we modify the code by ourselves and then request and ask for a pull request, or shall we ignore simply these warnings, or shall we hope that the maintainers of Coqui TTS would do what's necessary? So I think that's a simple question.
Yeah. So I mean, the best alternative is of course sending a PR, because it is already a solution. But if there's no solution, you can create an issue and explain the situation. So then we can take care of it. And if it is just a dependency issue, I mean, we can even help you on the channel. But yeah, it depends what kind of dependency you're referring to. Is it kind of a library you use, or it is kind of a problem in the code? So what kind of dependency you mean?
Yes, depend like in PyTorch or in TensorFlow or something like this. I have given an example in the discussions forum where I show some code what I have seen today. So,
okay, you mean the warnings, right? So I
yes.
saw the question about the warnings.
Yes, for instance, that the floor diff is deprecated, or that Torch mesh grid will be deleted in an upcoming version of
Okay.
Torch. So that's
Okay.
what I...
Yeah, I mean, you yeah, I see. So, I mean, as a user, you shouldn't worry about it. And actually, we also shouldn't worry about it. So it's a warning from PyTorch, and they should deal with that. And if there's any API changes in PyTorch, then we should. And if you need to change anything in TTS reflecting those changes, then we will just take care of it. So those warnings are normal. And once it's a problem, as I said, we are just going to deal with that. But if there is something we are missing, just feel free to create an issue, and then we talk about it more on TTS. Okay. So
Okay,
another question? Oh, sorry. You want to continue on that?
No, thank you.
Okay. Welcome. Another question or comment? Anything? Okay, so in the meantime, I share my screen so we see the questions on discussion. Okay, I hope I share the right screen. Yes. Do you see the
Yes.
forum? I hope you see.
I think Marco raised his hands.
What was that?
Marco,
again?
he raised his hand.
Oh, okay. Sorry. Yes, I saw it now. I'm getting used to it. Sorry about it. Yeah, go, Marco.
Okay, thank you. If nobody has a question for the moment, I will ask for a second simple question that I described in the discussion forum. It's about synthesizing test sentences during training. And there I often get the message that the audio amplitude is out of range and that the clips are auto-clipped, or that the decoder stopped with max decoder steps, or a user warning that value is too small for the input signal. And I usually ignore these warnings if the loss is decreasing as expected, but I'm not sure if that's the best reaction. So my question is, are there some recommendations how to avoid these warnings, or what we can do to avoid these warnings?
Okay, so maybe it's better to go over the questions because there are some examples, so we can see what kind of warnings we are mentioning. So yeah, I mean, let's start with the first one then. So when you synthesize the test sentences, you get this OD amplitude warnings, and then for decoders, you have the decoder length warnings. And then for synthesizing test sentences, there are some parameters. That problem. Okay. So like the first two warnings, they're normal, especially at the early stages of training, because basically the model is not able to produce good results, right? And that's the reason the output signal basically out of range. And initially it is normal, but after the training, after a couple of hours, or I don't know, once you see the model starts to converge, then those warnings should be removed. Otherwise, it means there's an issue. Then we should worry about it. But especially at the early stage, it is just normal to see those warnings. And okay, so if it is small, I can try
And
to.
the second also about the max steps.
So maybe just my screen, but it's a little hard to read. So
is it better now? I zoom in a little bit.
It's a little bit better now.
Now?
But it's okay. I can read it in a separate browser tab with live on GitHub. So just in case.
Okay. Yeah. Sorry about it. This is the most I can do right now. So I zoomed in a lot. I hope it works. So, or otherwise, yeah, you can just see online on GitHub. And yeah, for the decoder case, it's that again the same, because like especially if you use Decathlon model, there's the attention module, and the attention module should converge before it produces some reasonable outputs. And before this convergence, basically the decoder doesn't know where to stop. And there is a hard threshold for decoder so that we don't really bloat the whole GPU memory at training. So this is basically the warning saying that this threshold has been reached and then the decoder has been stopped. As I said, it is normal, especially early stage, but in the end, when the model converged, it should get away.
Okay, so that's only at the beginning where I should see these warnings, and
exactly. Yeah.
So my working is ignored most often these warnings. That's the right procedure to do.
Yes, exactly.
Everything went well afterwards.
Yeah. So if you're still having these warnings after the model convergence, that means either there's an issue or there is something wrong with the data, or there is something we should investigate. So it might be the code or it might be the data, but I will suspect the data first. And yeah, I mean, that means you can basically create an issue or ask for help on discussions so we can just investigate together.
Okay. Thank you very much.
Yeah, you're welcome. And Tristan?
When I'm right, isn't there a parameter in the configuration saying after which training step the training should generate the test phrases? So to avoid that problem, so that the test phrases are not synthesized by step 1 ongoing, but more after step 20,000 or whatever is the value there by default.
Yes, for inference, there's this value in the config that you can play with. So you can increase the maximum decoder steps or decrease it, and then basically you can give longer sentences as an input. But at the early stage in the training, I wouldn't suggest to give very high value for that field, because then you will basically crash your training if the attention hasn't been aligned. Because then as the decoder processes the sequence, the memory usage increases, and if there's no stop, and if the value is too high, then that means it will bloat the whole GPU memory, and then the training will crash. But for inference, that's right. I mean, you should find the right value for yourself for this decoder length, according to your hardware, basically.
But what I mean is not just adjusting the max decoder steps value, but I thought it is a parameter after which step the generation of test traces is beginning at all.
Oh, yeah. Okay. Sorry, my mistake. Yes, that's right. There is, yeah, I don't remember the field, the name of the config field, but there is also a parameter to skip the test sentences for a couple of epochs, or like basically you can just skip until the model converges, and then you can skip all these warnings. That's right.
I will look it up, and if I find it, I will put it into the chat, the parameter name.
Yeah, maybe even it's better to just post it there under the question. So probably it will be useful for other people.
You're right. Yeah.
Thanks. So, okay, this is that. And the next question. So the question is, it wasn't clear for me to beforehand which v0.5 model was trained on 44 kilohertz dataset, even the original paper mentions that they had trained on 22 kilohertz dataset. That's why resample is set to train the train width.py, because samples need to resample to the original dataset sample rate if one is to continue training from existing model. So I'm not sure what the question is here, but I guess there's kind of a confusion about the dataset, the sampling rate of the dataset and the targeted dataset for the model. So yeah, I mean, in short, this is true. So the dataset sampling rate is 44 kilohertz, and you need to resample the dataset before you feed it to the model. Either you can do it you can do it on the fly by just setting the resample field true in the dataset config, or you can resample the whole dataset before you start training. And you can do this using the resample.py, the script, and it will just convert the whole dataset, all audio files to target sampling rate. So, and yes, like in general, the models we train, they're around 22 kilohertz, because going above that, yes, it increased the quality, but also it increased the computational cost. And yeah, I mean, computation is not free. That's why we try to just keep it reasonable. I hope that was the answer. And if it is not, maybe he's here, School 101. So you can maybe raise a hand and expand the question. Trosten?
You said that more than 22 kilohertz, such as 44K, will increase quality, but also take more compute power to train.
Yeah.
Or just train, or to use it, the pre-trained model is more expensive on computing too.
Yeah, it's also more expensive at inference too.
Okay.
So
because
like as you increase the rate, the sampling rate, you also increase the length of the audio, right? So this is the length of the audio that the model needs to produce. So basically that increases the computation. And yeah, it depends to your requirements. If it is what you want, you can increase the kilohertz, you can get a better model, better fidelity. But yeah, as I said, it will come with a computational cost.
Because that's a question I've seen sometime in the chat. Why do we need, or why do we not publish the data set in 44K, or why? So I've seen that question sometimes.
Yeah. I mean, most production systems, they use 44 kilohertz, but they also use special TTS datasets, 40 hours and so. So, I mean, if you are targeting such a use case, like a production level, probably it's worth investigate 44 kilohertz, but even maybe initially experimenting with 22 or like 20 kilohertz is a better choice, because, you know, it will just double the computational requirements. And the next question: how to make a fast and best TTS system with Coqui TTS? I mean, it's a big question in itself. And there's a big prelude to the question. For the sake of time, I just skip that part and go to the bullet points. How to make a fast, best TTS system with Coqui, the first question. The second one, how to encourage people to share their experiences with Coqui TTS. And the third, how to prepare an optimal collection of sentences for training a TTS model. Yes, there's a related info in this repo, but is it possible for Coqui to start a new repo for data only, such as tools for selecting sentences for TTS-specific recordings, text normalizers, G2Ps, etc.? And yeah, I mean, great questions. So the first one, how to make fast and best TTS with Coqui TTS. So like it depends the requirements. I know it's not a satisfying answer, but as always, it depends. So if you have a data set which is created for TTS specifically, then actually it's really easy to get a high quality. You can just take one of our recipes and then pick the model that fits your requirements, change the dataset field, give your dataset. That's pretty much all. So it should work. And also best, the definition of best changes, I guess, based on the use case. So like sometimes you need a fast model that runs on Raspberry Pi, and sometimes you need a model that speaks good. So maybe I can give a spectrum of models. So actually I created the visualization before, but I never released it. At some point I need to add it to the documentations, I guess. So like if we take a spectrum of the model speed and the model quality, and then if you just, fill this spectrum with models, then I will say Decathlon models still the best, like the highest quality you will get from the TTS models. So they are not that fast. They are relatively hard to train because of the attention, but still you will get the best quality from Decathlon, especially if you use, it's kind of a self-promotion, but if you use double decoder dependency, then you will solve these attention problems. And then you will get a very high quality. Even the best model we released so far, it is basically Decathlon 2 with DDC. So, and especially if you have a data set which is just completely for TTS, that's all. I mean, you can just take Decathlon and that will just work perfectly. But if you like to have a very fast model, then I mean, there's the speedy speech, which is pure convolution. And it is like a very lightweight model, really fast. And again, if you have a good data set, it will just work as good as Decathlon, and you will have a very good performance in terms of the speed. Like you can put it in the Raspberry Pi, you can put it into your Android device, and it will work in real time. So it's quite good. And like if you also fill the gap with different models, then I will put Glove TTS just next to Decathlon 2. And I mean, it will give a good quality, as good as Decathlon, but the pros that you will get is not as good as Decathlon. So maybe someone could try, I don't know, taking the Decathlon 2 encoder and then merge it with the Glove TTS decoder and get the best out of both of these models. So it will be a nice experiment. I've never done that, but it looks reasonable. The other good thing about Glove TTS, because it is a generative model, you can do all kinds of tricks like voice cloning, voice adaptation, and like all these different stuff with different tricks, which are interesting to investigate. So you can also do all this with a single model. And there are also some other models, as you know, like other forward models, like fast speech, and align TTS. I mean, if you have a computational budget, I would say just take all the models, just run all the recipes on your data set, pick the best model out of the all. So like just experiment with all of them. But if you don't have that budget, I will start with Decathlon. And then if it doesn't work, then I will take another model. The next will be Glove TTS, I would say. And yeah, I hope it was a reasonable answer for the question. And how to encourage people to share their experiences with Coqui TTS. So actually, we don't, I mean, the one way is, of course, writing about it somewhere, maybe in a blog, and sharing it with us. Or you can write a thread in the discussions. You can write on our Element channels or Github channels. Or another option is that Trosten created already a very good website for open speech tag. He created a wiki page. So I don't remember the wiki URL, but basically, first you go to Twitter, follow Trosten, then there's the link for the wiki. You go to wiki and write your experience there. I guess it would be a nice contribution. So like, I don't know any other wiki which has the same content as Trosten's wiki. So like, we can basically collect all the open speech experiences, all the speech knowledge in there, so we can expand it together.
Thanks, Aaron. That would be great if we can bring all our passion and knowledge to one together. That would be nice.
Yeah, exactly. Okay, so how to prepare optimal collection? Yes, so the data preparation. Yeah, currently we don't have any tools to do that. We have some like hacking notebooks to do some analytics on top of your created data set. And yeah, I mean, I think it's a good idea and we are going to do it at some point. But for now, I guess it's not in our short-term plans. But if someone starts to do it, we are happy to contribute and like expand the library together. So the short answer is basically we are going to do it at some point, but I don't know when. And definitely it will be a nice contribution to the community because it's a hassle. Probably also Trosten knows more than me. And okay, so that was all for this question, for this thread and the next thread. Okay, we already talked about this, the warnings, and the next one. Any other ways to evaluate? Testing out various model performances. Any other ways to evaluate is not using the alignment curves and the loss curves. Is there a better way to do it than mean opinion scores? Try the test attention notebook, but it simply brings an error of invalid notebook. Yes, I know. I mean, the notebooks, they're not part of the CI currently. So if they fail, they fail. And unfortunately, it is up to you to just fix it. But in general, the problem is mostly some of the like config fields or, you know, just small errors you need to fix. And I know it is not the best way. So this is also one of the problems we need to deal in the future. So like basically provide more tooling, which are really part of the library that will do all these testings for you. But in terms of evaluation, I mean, if I train a model, the best way to evaluate is just get some opinions, like mean opinion score. But it's not easy. You need to pay, you need to do mechanical Turk, you need to do some stuff around it. So it's not easy. Another way is that you can train a speech recognition model for that speaker and then use the speech recognition model to do some, you know, basically create some speech with TTS, use the speech recognition model, and use the word error rate as a metric for the quality. It doesn't say a lot about the prosody and the naturalness of the speech, but it will say about the general quality of the model. So like it will give some intuition. And then there are some other metrics you could use to just evaluate the clarity in the MEL spectrograms and the audio signal like SNR and some other metrics. Like you can basically aggregate all these metrics and come up with a single value. But that value, actually, how you combine this all these metrics is about your use case. So you should find the right weighting between those metrics. But again, the best approach is mean opinion scoring. And actually, it is not mean opinion scoring. So like, I don't like mean opinion scoring because it is not a fair way to compare models. I think that the better approach is that what we have done before for TTS. So you should actually, like the use case for your TTS is to just provide a better experience to the user, right? So I think you should just give a couple of alternatives, maybe the real voice too, and give kind of a content that will be consumed in your real use case, and then give all the outputs to the user and ask their opinions about like which one you would prefer to consume this content. So then I think it's a better way to evaluate the quality, because maybe the TTS is better than the other TTS model, but then maybe the other TTS model is better to consume the content. So basically, you should define that criteria according to your use case. And mean opinion score doesn't really reflect that. Okay, so I hope it was an answer to that. And the next question. Oh yeah, Trosten, sorry.
No, it's just I have to leave now, but I really enjoyed it, and I'm looking forward for the next session to come, hopefully.
Okay, thank you.
Bye.
Thank
Wishing you a nice day.
Thank you very much, too. Okay, choosing models for faster inference. What are the best models for the fastest inference with a single speaker LG speech-like dataset? I have trained a few of the models, but it is not possible for me to train all possible combinations of the models due to resource limitations. If someone has already tried the various combinations of the models, it will be nice if they report their RTFs. Okay. So I guess the concern here is more about the real-time factor than model quality. So if it is the case, as I said, you should start from speedy speech as an architecture. So it is the fastest model we have. And if it doesn't work for your data set, you can just like step by step increase the model architecture. Or like you can increase the model size, or you can try some other similar models like fast speech, fast pitch, and you can try other models. And like I will say, at the end, at least fast pitch should work for your data set, and at least produce some reasonable output. But as I said, if the RTF is the concern, you should start with speedy speech. Okay, next question. PyTorch versions and memory consumption. I had to dramatically decrease my batch size with PyTorch Coqui version compared to yada yada. It would be great if you could share a discussion about this. Yeah, the problem with PyTorch versions is that actually it depends how. I guess he's here, right? So maybe you can expand the question a bit, because like there are some versions of PyTorch, and even how you install it basically changes the way it works. So for example, if you use Conda and if you install a certain version of PyTorch, then the memory consumption is different than the other version of PyTorch installed with pip or some other, some other way. Like it is not mainly a Coqui TTS issue, but it's mainly a PyTorch issue, and it's about the the computer you use and the setup you have there. Or at least this is my experience so far. Like because I remember, like especially with Edrison, I guess we discussed this. Like it happened to us as well, but it was just installing the whole setup environment again, and it just disappeared. So like all these memory issues. I hope it is the same for you. So like basically reinstalling or using a different version might be a solution. Are you here, by the way? So maybe you can add some bits on top of it. Adam? Okay, I guess he's not here. Okay, the next one. I guess we talked about this at the beginning, so I skipped that. While loading data into Dataset training.
Okay, so that's again a question. It's a very specific question.
Mm-hmm. Go on.
You hear me?
Yeah, I hear you. Go on.
Okay, so question is, I training a small data set with about a few hundred utterances.
Mhm. I don't know if I'm on. It's only me, but I guess you're cutting out.
Yeah, the audio cut out.
And I've seen that the data is loaded in 2 steps or 2 stages.
Mhm.
Hello?
Now you're back, but you were cutting out.
The data set is loaded -6.
No, I don't hear you, unfortunately. So I guess connection is kind of bad. Can you try again? Yeah.
You hear me? Or perhaps you can try to read the question.
Okay. So if it's the same question, I just go over the question then. Okay, so when training a model with a small data set of n utterances, my data is loaded in 2 stages, and 6 samples at the start, followed by 6 samples a few moments later. The logs of data sets, 640 utterances, are shown below for the model that got run to the VBCA, but the same happens with our models. I don't understand why the loading is done 2 stages. What is a batch group? What means size 0? I tried to read the scripts related to dataset or flowcharts without success. I guess there are easy questions for Coqui TTS. Thank you. Yes, so the batch group size is basically about bucketing. So bucketing means, like, if you train the models and if you use our TTS data loader, what it does is that it sorts the sequences by length so that we don't waste computation to do paddings. So, but if you always sort the data set and then ingest it, you would always give the same order of samples, right? So there's no shuffling in that. So the model always gets the same order. So to prevent that, any kind of possible overfitting to that data, we use bucketing. So the bucketing means, so if you define, for example, batch group size 2, that means we first order the whole data set and then create batches. And we take 2 batches and then randomize the samples in these 2 batches before we ingest the data to the model. So it is kind of a shuffling, just we applied after ordering, but before feeding the data. So it's kind of it's basically shuffling. And the batch group size basically defines the size of that shuffling, the bucket size. I don't know if it was a good explanation. So is it clear?
No, not totally, because the data set is shuffled during the pre-processing. And then it's the trained and the validation list are saved into the pre-processed data.
You mean you mean before the data loading or in the mode? I didn't hear you. Sorry.
You might want to reconnect it. It sounds like it's a connection issue. It's not like a microphone issue. Maybe reconnecting to the call will help.
Can you try again?
Yes, I will. So I understand that our dataset is shuffled during the pre-processing, and then a training list and a validation list is generated and saved into the pre-processed data.
Okay. Yeah,
Then
that's
when loading, I
yes,
find
I mean
there
that's right. Actually, there's no shuffling in the pre-processing step. So like when you load the data, just loading the meta file of the data or the manifest file of the data, creating basically samples, list of samples. There's no shuffling there. We just read it from the file with the same order. So then once we load the data, give it to the data loader actually sorts them by the length. So from the shortest to longest, then we sort the samples according to the length. So then after that, if you define a batch group size, then actually there is one additional shuffling applied to the samples before feeding the next batch to the model. So this batch group size basically defines the strength of this shuffling.
Okay, I will try to read the code and to understand it. It's not yet fully clear for me, but thank you for the explanations.
No problem. I mean, if it is not still clear after reading the code or like checking the library, you can continue the discussion there under the thread. So I can even try to, yeah, I can even link the code, I guess. So it will be better. So I can just put the link after the code, so you can see which part of the code actually does this.
Okay, thank you very much.
Yeah, you're welcome. So the last question, loss curves, the heading and hi when training a TTS model, which script command we should use to plot the loss curves. Okay, so you have two options currently. One is you can use TensorBoard. So this is the default option. Any model, any training you starts with a TensorFlow logger, TensorBoard logger. And then that logger actually shows all the loss curves, all the statistics about your data, all the metrics about your model quality and so on. So you can basically use the TensorBoard as the answer in the thread. Or the other option, we also support weights and biases, and you can use their UI and their logger. You can basically change the fields, the logger field in the config, and then you can choose weights and biases. And you need to do some additional settings too. I don't remember what, but you can, I guess, I'm sure you can figure it out. And yeah, basically these are the options for now, but also we are working on MLflow to have like a better coverage for the training management. But for now, the best solution and easiest solution is TensorBoard. Okay. Is there any question? Maybe I just missed a raised hand. Yes, Ayman. I'm not sure which one is the right pronunciation of your name. Ayman.
Hi all. Yes, Ayman.
Ayman. Okay.
The last question is mine. I work on TTS applied to Arabic language.
Mm-hmm.
The TensorBoard logger, where I find it exactly, in which folder?
Okay, so if you start the training,
Yes.
Can you I hear myself. It echoes.
I didn't
hear.
hear.
Can you mute?
Yes.
Okay, I hear myself. Okay, so once you start your training, so there is the output folder for your training, and under the output folder there is the logging file for TensorBoard. So this is basically the file and you need to run TensorBoard, first install, of course, like pip install TensorBoard, and then you need to run TensorBoard on your terminal and point that folder, the output folder of your training, using the right argument. I don't remember the argument now. I guess log there or something like this. So you need to just call TensorBoard on the terminal, and then you should go to the browser and then see the right address, and the TensorBoard will be there. I guess there is something in the documentation of TTS about that. Let me see. Okay, go on, Armin.
Okay.
Is it clear?
Yes, it's clear.
Okay. Yeah, great.
Eren, may I ask a second question?
Yeah, sure.
I train my dataset on Wave RNN decoder.
Mhm.
It shows good results, but when in inference time for a 10-second audio, it takes 600 time to generate an audio. Is it reasonable or not?
Can you mute? Yeah, okay. So it is reasonable. Wave-RNN is unfortunately the slowest vocoder we have. Relatively produced the best quality, but the inference time is quite high for Wave-RNN. And especially if you run it on CPU, it is really extremely slow. So the solution would be just try another vocoder we have, like Hi-Fi GAN, UnimNet, or something based on GANs. Or there's also Wavegrad. It is also similar to Wave-RNN. It produces, again, very high quality, but it is actually faster than Wave-RNN. So maybe you can even try that. But if the runtime is an issue for you, then I would use Hi-Fi again initially.
Thank you very much. I'm very pleased to be with you today.
Okay, thank you very much. Good to hear that. Jerry?
Okay. Thank you very much, Eren. My question is similar to the previous about the vocoder training. So I've tried training with the Wave RNN, and also I tried with the Wave GAN. But the issue I face is that I've never successfully gotten like a sound, because normally when I synthesize without specifying the vocoder, my output is like fair, it's good. But when I train my own wavegun and or Wave RNN, the output is like it's like no output. It is a really bad output. Actually, you can't hear sound, but you can synthesize without specifying the vocoder, and you hear like a good output. Yeah.
Okay. So, I mean, I'm not sure what the issue is, but like some of the possibilities are, so one common mistake is that the audio parameters between the encoder model and the vocoder, they don't match. And then if it is the case, basically the vocoder cannot produce the right output for the model. If they're okay, if you're using the right audio parameters, then basically maybe you need to train the model more, vocoder model. So if you also train the model well, and if you get some reasonable results on TensorBoard, but it doesn't work with the encoder model, so then I will suspect there's something maybe behind the code. Maybe you should create an issue, or yeah, like most probably there's something about the code then. Like if it doesn't work even after you get some good results on TensorBoard. Is it enough? Yeah, Jerry, go on.
Okay. So just one last one. So normally when I don't specify the vocoder, which vocoder is being used, especially for like Tacotron 2?
Okay, so Let me check. I don't remember. Even we can check it together.
Oh, okay.
So let's go here. So basically, this is the file that lists all the models we have. So these are TTS models, and if you look at the default Decathlon model, it uses Hi-Fi again as the vocoder, Hi-Fi again version 2.
And this hi-fi gun is trained while I'm training the model, or it's like a different one?
So let me check. And this Hi-Fi again is here. So this is the model. And this is basically trained on LG speech from scratch.
Okay, so English.
Yes, exactly.
Okay.
And like
Right.
if you have a different, are you training on English or you are using a different language?
I'm using a different language, but the output is better than when I specify a vocoder. Like, I've never been successful with a vocoder. Yeah.
Okay. Yeah, but you are sure that the encoder model actually produces some speech, right?
Yeah, when I don't specify the vocoder, the output is good. It's okay. Well, it's not the best, but it's okay.
Okay, so then there's something wrong with the vocoder. So I will suspect there is some mismatch in the audio parameters.
Okay, cool. Thank you.
Yeah, you're welcome. Okay, we're already beyond the time, but if there are any questions, I can still take a couple of more. Maybe not question, comment, or anything else. Anything to say, discussion points, or whatever. Okay, 5 bars.
Hi, Eren. I am on the phone. So I wanted to ask something a bit more niche. Probably the answer is yes, but you can point me in the right direction. I am also trying to, I trained the model and I'm trying to train the vocoder right now, but just in case, I wanted to know if we can simply generate the spectrogram with the TTS command, and then I can feed the spectrogram to another vocoder. So is there an easy way, or I have to go into the code? I mean, I saw that we can write it, but is there a way where I can keep it in the memory and pass it directly to my own vocoder, the spectrogram?
Yeah. So there's no way to keep it in the memory. So what you can do is that there is this choice. So there is this script, extract TTS spectrograms, and that supports a couple of models, not all of the models. So it supports Globe TTS, Decathlon, and one more, I guess. No, only Globe TTS and Decathlon. So you need to use this script and produce MEL spectrograms, and then basically you need to point that folder in the vocoder config, and then the vocoder will just fetch those files instead of computing the MEL spectrogram from the audio file.
Okay. Okay, thanks. I don't think it helps. I have a model with a speedy speech, and I have my own vocoder in Melgan. But anyhow, I will check the code to see what's going on. Thanks.
I mean, one thing you can do, like, it is very easy to add a model here. So like you can add the speedy speech to this script. So basically you need to basically, copy and paste and change a couple of fields probably for speedy speech. And then you can compute your output. Or you can use the notebook. I don't know how compatible it is now with our models, but yeah, there's this notebook as well. So, like the notebooks, extract TTS spectrogram.
Okay.
It will not load. Yeah, it loaded. Okay, so you can also use this notebook again, like a warning, I don't know how compatible it is now, but it should give at least some idea how you should do it.
Okay. Okay, thanks.
Yeah, you're welcome. Okay, so I think it is time to end. It's been already 1 hour, and yeah. So thanks everyone. I mean, it is the first community meeting. It was kind of exciting, and even like maybe before we finish, I have a couple of thanks to say. So Edrison's here, and Weber is not here, unfortunately. I mean, I like to thank Edrison specifically because he's our main author in our first paper. He's the main author in our second paper. He had created a lot of models for us. He created the SC Globe. He's also working on our latest paper. It's not shared yet, but soon to be shared. So I really thank Edrison for his contributions, and also Julian. Julian also had a lot of stuff and like helped a lot about the API decisions, a lot of fixes. And if you are there on our channels, you already talked to Julian probably. He also helps a lot to community. So I really say a lot of thanks to Julian. And also Trosten was here initially. He left, I know, but maybe he will see the video afterwards. So big thanks to Trosten for his dataset, his work in German specifically, and his new wiki about open speech tech. So, and also big thanks to our contributors. Definitely, I mean, the reason that we have TTS is basically the contributors and the people who use it. So yeah, keep using it, share your ideas, issues, and basically we solve TTS all together, I believe. So that's pretty much all. And I guess, yeah, also afterwards, just feel free to share comments and feedbacks about this talk, this meeting, how we can make it better, what you'd like to see the next time, and so on. Yeah, that's pretty much all. Thanks, everyone, and see you next time.
See everybody. Have a good one.
Yeah.
Bye-bye.
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 Bye-bye.